Right, so we are now looking at physics for the lower primary, and then we are looking at the ages 6 to 8 stroke 9. So that is for the lower primary. Right, so the first topic we're looking at is motion. Okay, right, so some may also look at the preschool. The preschool to have something for them. So as we do motion, this is introducing them to the various types of motion. Okay, so we are more particular about they getting the physical aspect or the play aspect. So we look at the play, which can go for both preschool, okay, and then the lower primary. Okay, so under motion, when it comes to our play, we are looking at, so you should get our toys, or if you have the toys available, you can request for it, it can be sent to you. So we have play toys, or the toys for motion, which we describe. So maybe we have a vehicle like this. Okay, then we have a circular part so this will be going through, then we say it is circular motion. Okay, then we can have another one like this. It's a hand here, and then we have a small ball attached to it. Then we swing it, it goes to and fro. Okay, so this is describing the simple harmonic motion. Then we have one that maybe the car can be made. So this is going to be done in a form of play. So we have the play set out, okay? And this is going to go straight, then we'll call that linear motion, okay? So basically the play is on this. We have the toys for this one. They'll be playing with it. Preschool will be playing with these toys. So as and when it's time for physics, and then the topic is motion, this is what they do. They do the play around this one. Then we have the last one. We have what we call let's say the fan here like that. Attached to it is this. Now this will be one to move in a circle. Okay, so it will be moving in a circle, and this is under rotational motion. Rotational motion. Okay. Right, so this is going around like that. There's a point here, okay? If this happens to be a body, then we can, if there's a body, let's say one body, another body here, okay, then we'll say this is revolving, okay, so that will be revolution, okay, but this is not what we are describing, okay? We want the path, the circular path that is going, the path of motion, that is what we are interested in. So we are looking at circular motion, simple harmonic motion, linear motion, rotational motion. So the play is there for them. So we have the toys. If you are interested, you can request for it. It can be sent to you in a form of package. Okay. So this is what you're going to do for motion. So as a teacher, you can just let them draw. Sometimes you can let them sketch. Okay, just by sketching, and then you do it with them. Then after sketching, so the sketching is done by the lower primary, but using the toys can be done by both of them. Okay, use the toys to pitch this. This can be done several times. You can let them rotate, have 3 or 4 groups, okay, and then they'll be doing this over and over. So this is under motion, and that will be a very good thing to cover all the aspects of motion, so that by the time they get to the upper primary, they are ready for the takeoff, right? So this is what you're going to do. Sometimes you can also have another one, select one like that. Okay, you have something like this structure is also designed, the wheel, okay, like a disc, okay. Now this disc is made to move down, okay. It will be rotating, at the same time describing the linear motion here. So we have 2 types of motion here. So here one is moving in a straight, at the same time it's rotating, okay. And this is a sledge, okay, that's so a wedge. This is a wedge, okay, with a certain angle. So this is just preparing them for future, the types of motion that we'll be talking about. Right, so this can be done. These are all the play tools that we have. You can look at it, get our play tools for this kind of motion, and then let them. So there's a lot of them. We also have the we'll get to that point, but I'll not add this for motion, so I'll just leave it here. The most important thing that we are emphasizing on is we are describing something like circular motion, describing something like simple harmonic motion, to and fro motion. We are describing a linear motion, we are describing rotational motion. The rotational motion, this can also do. Right, so this is just to introduce those in the lower primary to the various types of motion that we have. Right, so let them join in the play, right? Now let's come to the next topic, forces. So we are looking at the various type of forces that we can talk about. So we can have, let's say, here, we have a word here, then this beam is on it, okay? The usual, what do you call it, planks, only one of them sits here, the other sits there. You can let two people sit here, then this goes up a little. This one is a play for them, okay? So you, the or the assistant or the teacher, should be around to help them, okay? So as they do this, you can let them move this one, the bar a little, change them until they are kind of balanced. Instead of doing that, you can sometimes use blocks, okay, to do it, and use blocks to also do that. So that's the play for the various type of forces we are looking at, okay? Right, so we can also look at another one. What you do is you have a box here, you tie it to the rope here, tie it to another rope here, okay? Now you let two people be pulling this one here, so it is the direction of the force. Then the other two will also be pulling it this way, okay? You see that it will move in here, okay? So this is just trying to let them get the concept that when two forces are being pulled apart, so this force one, force two, you'll be getting the resultant force for the two will be in between them, okay? So this is about forces, and then we have you can just do the normal play like that, okay? Somebody will be pulling it, just to show you are using some sort of pull here. Then you can have another one, maybe turning, they will be twisting it, okay? So there's a twist, okay? So these are describing types of forces, So this is the play, okay? As they do this over and over, they are getting the concept. Alright, and then you can have another one, maybe rope tied to strings, and then they whirl it around, okay? It's whirled like that, okay? So you see that this is always being, there's a force that is keeping it in constant motion. That's when it's going. As this is trying to move away, so this is your centrifugal force, and the one directed towards the center is the centripetal force. Okay, so as we do that, we are just getting the concept. They are getting the concept as they feel it. That is how to be. So this will be a good, because they need something concrete to look at, and then to learn to. So the person is holding it and then whirling it like that. Okay. So this ball is not moving out of the circle, it's still kept in the circle because there's a force that is keeping it. That force has balanced the one that is pulling. Of course, this force that we are talking about is not a natural force, it's something that is felt. Okay, you feel it, but it's not a natural force. Just at this point, let's leave it like that when you get there. So this is a circular motion, okay? So that force, okay? So the force, we are looking at something pulling, something twisting, so, right. Okay, so this play can also be there, this just to guide us. Now, sometimes too, you can also let them have a ladder, like that. Maybe something small, you can climb up, you can, okay, this is giving the concept, okay? And sometimes you can slide it like that. Okay, you can keep on changing the position, okay? So this just bringing into force movement and those things, okay? That's the concept of movement is trying to impact, okay? Now we can also have the balls like that. Another ball. One person rolls it, this one rolls it. Then they will collide. Okay? So we are looking at this point, we are looking at momentum. Okay? Momentum conservation, that is what we're looking at. Okay? Then you can let another person, maybe a person stand like that, will turn round and then later fold the arms and turn around. Okay, so this is also describing angular momentum, angular momentum. Okay, and this is describing linear momentum. Right, so just to get the concept, okay, and then this one is in the form of play. They should be involving basically. If you have swimming, they can just do swimming, and then that is also part of the exercise. It's an exercise. It's also going to give them a kind of motion. So when you are swimming in the water, the person moves faster than the other. It's giving the concept of motion, and then velocity, speed, and so on. Okay, so that is how it is, right? Then you can also let them try the force of gravity kind of thing. Let them try. So these are ways of getting them to understand what they will taught in future. Okay. So the next one that you can look at is you can have something here like that. A ball here. You roll it over, then force. You can also push it so that it goes in the pathway like that. So it describes a parabolic, a parabola kind of path. Right. So this one is just for. So this is falling under gravity. Okay. So this is also going to fall under gravity, but it's describing a parabola kind of path. Okay. This concept will come in. Right. Okay. And when they throw something up, they should throw something up and then come down. If they are up there, if they are up here, they can drop two different things at the same time. This is a different mass. You drop them at the same time and see which one will reach. You see that they will all fall, get to the ground at the same time, equivalent. Approximately they will get to the ground at the same time. So they're trying to bring the concept of gravity, the same force of gravity in each of them. So that will make them fall at the same rate. Okay. For air resistance, we'll make this one probably not move faster. Right? So that is that. That's the concept we are trying to get here. Right. So your gravity is the same as your acceleration. Acceleration due to gravity is acceleration. Okay. And it's telling you how your velocity, your speed is changing. Okay. So when they talk, let's say, okay, someone is moving this way. He's moving with a certain speed. Okay, another person is also moving with a certain speed, maybe this way, with a certain speed. Okay, so the two together, this one has a certain velocity. This also has velocity in a certain part, but each of them has what? So let's say velocity in A direction, velocity in B direction, but each of them has speed. Then you are trying to bring into the picture vector quantity and then scalar quantity. There's something like that. Okay, so let's say one moves this way, another person moves this way. This one has speed, this one has speed. Okay, but this one is velocity in direction A, velocity in direction B. So let's just don't try to let them understand. Okay, just mention information. As we do that, we'll be doing this over and over for 3 years, remember. Okay, so by the time they get to the upper primary, the concept is there. So the play is okay. The toys are there, you can request for them. So we have play for forces too. The play tools for forces, okay? So you can get all the play tools you make payment and then we'll be delivering them to you in store from time to time. And then you can be paying them over and over. Right? So this is for forces, okay? You have the play tools for forces, the type of forces. You can also look at forces in fluids, okay, which is going to be very important in our discussion. Because forces in fluid. So this is kind of preparing them. So the forces in fluid in here, like water. So this thing, when I sketch to you can let them also sketch. Instead, if you don't have the play tools, you can let them, those who are in classes 1, 2, 3, you can let them sketch. Try whatever they will sketch, just put it there, let them also try to sketch. Just by doing that. So it makes them remember. So the first thing is the play and to sketching. Okay? Sketching is very important. See, the attempt to do it is also learning. Okay? And then here you can really talk about maybe teaching and then explaining, talking. Okay. Right. So here you can have one ball here, have a bigger ball here. Okay. Right. The same, and then see which one will go in, which one will not go in. Okay. So they're trying to see, and then they'll be pushing it, is floating. They will try to push it down. So here is to describe what flotation, and then also Archimedes principle, which is the upthrust. Okay, we'll also be looking at upthrust. Okay, so law of flotation is there, then they look at upthrust. So the water is also pushing against it. As you are pushing this one, water is also pushing again. So that's the upthrust. That's the kind of force. So this is going for Archimedes. Okay, Archimedes principle. Right. So that's go for Archimedes. Archimedes principle. Okay. For flotation, they are all going in the same principle, the same way. So this is just relating to weight. Okay, this is relating to upthrust. Okay, right, but they are linked by the same concept. Okay, so that will be in fluid. So you can also look at the fluid with narrowing. So fluid flowing through this one, and it's narrowing. Okay, how the water spreads out. You can do that. The hose, you have the water hose. They can play with it. Okay? It's a concept that we are building with fluid flowing through pipes and all that. So this one, you have the play tools for all these ones there. So you request for them, we make the package and deliver them to you. Okay, so let's get our kids playing, sketching, and then learning. Okay, that is the concept for this lower primary. Right. Remember, the English is also there. The books are there. The audio is there. Right. So these are to help them. Okay, they have to learn in the form of play, sketching, and then listening. Okay. So right. So this is under forces thing that we'll do for now. Of course, you can also look at the concept. Okay. We have a straw here. Maybe you put a straw in. Okay, it will be working like that so that the concept of refraction, okay, can come in there, right? So as we expect it to go, that this doesn't happen. This is what we are seeing. All those things can be there. Okay. Good. And then if you have, let's say, a fluid collection, put the pipe in straight like that, you tilt it and see. So the level will be the same. So this we are trying to tell them pressure. Pressure in the fluid and it's the same at the same level. Okay, same level equal to same pressure. Okay, so that's the concept we are trying to create there. Right. So and then when they are something is moving and they are there, let's say in front of them air is moving around them. So we see the velocity of air and then as again the time. Maybe you can illustrate with some fluid moving things like this air column moves around that, move this way. This thing may go up. If you move something like that, it may go up because of what? This is going to move faster. It's the same velocity is not moving. Because this is moving faster, the pressure will go down, and this is the same, so the pressure is higher, and then this thing will be, this ball will be lifted. Okay, this is something like talking about the noise principle. Okay, but at this point we are not talking about it. We are not supposed to mention these words to them to frighten them, but it's just to get the concept. Okay, get the play around them. Okay, then for the future they'll be using this one to get the picture well. Right, so that is how we're going to build them up for our upper primary and then subsequent classes. It's also at this point when you keep on doing this, you'll be building the interest in science, especially in physics for this particular topic. You'll be building their interest in physics, right? Now let's talk about energy. So we have different forms of energy. So you can let them describe it. Okay, so the play and then the sketching. Okay, so let's see this ball here. Okay, it has a certain height, okay? When it's dropped, it falls, okay? And as it's falling, it's moving. So it's moving, so that is kinetic energy, okay? Then when it is here, it's not moving, it has what we call potential energy because of the height, potential energy, okay? Right, it's falling because of what? Force of gravity on it, the force of gravity. Force of gravity. So this is the Earth's surface, okay? This is the Earth. The Earth is pulling all objects towards its center, okay? With a constant we call the acceleration due to gravity, G, right? That's the Earth is pulling all to it, okay? So there are different forms of energy. So this is potential energy, kinetic energy, just demonstrated out. You can have a spring, okay? Attach to it and that. When it is stretched, you can have it this way. Okay, so this has some energy in it, okay, stored in the form of PE. Okay, when it's stretched and then released, it will move, it will do upwards movement and then downwards movement. Okay, that is a to and fro kind of movement. There's simple harmonic motion. Okay, that is kinetic. So we have some kinetic energy in here, alternating with potential energy. Of course, there will be some constant in this constant K in this, which will be making it move. And it's moving with certain distance x. Okay. So just play, you don't need to talk about all this, just let them play with these swings. So you can tie it and then you can also let it be in the horizontal position. And then pull. So we have all the play tools like this you can order for them. So these are just to help the kids. Of course, like I told you, we have done research and know by doing these things, you will be able to sort of put up interest in science in the kid. So there's that. You can also look at what we have talked about. Some charges. So maybe you have comb. You comb your hair and then use it for pieces of paper. Okay. Attractions. Okay. So we are looking at electrostatic. Static forces. Okay. So that play can come in. Right. That is also there. So all these ones are adding up. We have already talked about gravitational forces. Right. Then you can talk about electricity. Electricity, these are all forms of energies that we're talking about. Electrical energy. Okay. Electricity. So if you have a battery there, you connect them. If you have a small motor that you can have maybe something like a fan connected to it, okay? You add two batteries, you see how to move three. Okay, so you have a key in there, okay? Three batteries, you see how it moves. So this is telling you electrons are moving, okay? Electrons moving is current, okay? And current, okay? If this would be direct current, okay? You can have those we are getting from Akosombo. So maybe we sketch something like this, Akosombo, okay? We have our river coming. Then we have some machines in here, like fans, okay? So something that they are familiar with, okay? So this goes, is turning it. When it turns it, electricity is formed. That electricity moves up and down, okay? That electricity current moving up and down. That we call it alternating current. That is what we are getting from Akosombo. Okay? This one is coming from the battery. So this is the battery. So this is the direct current. This is coming from Akosombo. We are getting alternating current. Just mention something like that. Okay, so this is the river coming. Okay, sketch. Right, so we have play tools like this for that. Okay, and this is just an illustration. Right. Good. So the next thing, once you bring this one, you need to be good to bring in magnets. So we have two magnets there, North Pole, South Pole. North Pole, South Pole, okay? They're supposed to go like that, so it will come in. So they are going to attract me. They are going to attract, okay? So they are going to attract me. 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 So they are Okay, so the two are going to attract. The direction is where a north pole. If you are bringing a north pole here, close to this north pole, let's say another north pole here, and bring it. It will push it back because they are the same. Push it back. You are bringing the same here, so if I'm bringing the south pole here, it's also supposed to take it right. You are going to pose, okay, so it will repel. So this is going to be, it's going to repel, and this is going to be what? It's going to attract. Okay, so let them play with this. So these are play tools, okay. So these are all forms of energy that we're talking about. So the play tools are there. We are playing this, okay. Instead of having this one, sometimes you can even put light bulb above there. So it lights up. You increase the number of cells, it lights more, and so on. So this is important. So, okay, that's the load. This is the load. According to the load. So this is just building the concept, bringing the various. So the play tools are there. You can order for them. Each topic you have the play tools. So if you can't afford all of them, you can ask. You can get them on rental basis. You get it for some months or weeks, so that they can have a variety. They can be changing over and over. Okay, you make the request, we give you. If you can't buy them, you can do the rotational kind of thing, right? And that is going to be interesting. So I'm sure at this point people are getting interested. So we just get in touch with us and get the play tools. So after from the play tools, then they go to sketching. Okay, so let them try to sketch what we are doing here. Let them try their hands on. So by sketching, we know why we say that. So if we are very conversant with sketching, it's helping them to conceptualize. Okay, so we have what you call the spatial orientation, and that is going to help them develop one aspect of their brain, which is a little to the posterior part, the back part. Okay, we are interested in that because we have some mathematical portion. The portion of the brain for calculation also close. Okay, so we want to build up all this. So all that we are doing, you see it as simple, but research has gone into it, and that is why we are doing this. Right? So you can also add. It's important we talk about the electromagnetic or magnetism. Okay, so you can also have your wire going on like that. You put a nail in here, have your wires connected. Okay, just to see the relationship between electric current, okay, and then magnetism, okay. So you can do that. So this going around a nail or something. Then this is a battery. Battery is in there. Then which is battery is made up of what cells? Okay, this battery. So we have cells coming together, or we can have cells. We usually use this symbol for the cells. Okay. The cells together form battery. So that is that. Or you can also have the magnet. You try to have another magnet, another metal here. Right? You can stroke it to see if it becomes magnet. So try to magnetize. Some to just bring close to it for a long time and see. So some which are ferromagnetic. Ferromagnet, okay. They are, after taking off the magnet, they retain their magnetic property. Then you have the paramagnetic or paramagnet, okay. These ones, paramagnetism, so ferromagnetism, another paramagnetism. This one, when you take off the magnet or you take off the source or the source of the magnetism, then the object loses its magnetism, okay. Diamagnets will not. They are not going to show properties of magnetism. Right? That will be the diamagnet. So these things, they are related to the electrons. Okay, how the electrons are related. If the electrons are moving in the same direction, okay, they give you the magnetic property. So we call each of the directions, we call it the domain. Okay, if they are oriented in the same direction, they will give you the same. Let's say maybe this becomes north pole, this becomes south pole. Okay, if they are not in the same direction, then you have a problem. You are not going to have magnetic property in that thing. Okay, Right. So the degree to which they are oriented will tell you how they are able to retain their magnetism as ferromagnet, or if they are not able to retain it, then they are paramagnets. Okay. So this is just concepts we are bringing in here. Okay. Right. So the sketching. So we play, we sketch, so then we are progressing gradually. Right. So that is that. We move on. Now we come to the optics, okay, and waves. So you can come to light. Your light is also a light, okay. Light energy, okay. So you have your torch here. Okay, it's giving out light. So this light. So we have the rays, light, all together forming the beam. Okay. The thing is there, we can also look at it this way. That this light is made up of waves. It's made up of waves, okay? And just do that, okay? So that we start getting, and this wave is coming in two parts. One is going like that, another is going like that, okay? One going, this is, let's say, the magnetic one, and this is the electric field, okay? Electric field. So this is light, okay? So this is just trying to get a concept there. Okay, they are at 90 degrees, okay? So, and that is going as the light, okay? A pack of it is what we are going to call photon, okay? And this can be like a particle, sometimes, and then as a non-matter too, either as a particle or non-matter or wave, okay? So we can also look at the sea, or water. If you take them to the sea, the coast, they will see this one. So these are the waves, okay? At least they see what waves are. Okay. Now the level of water, let's say this is the beach. At this point they are here, at that point they are here. So this is talking about the tide. So the tidal waves are there, but the tide is going to be the level. So this is reference to the level of the sea, okay? The tide, okay? So we are looking at the tidal waves through the terms of the level change, it's also coming. And then the individual movement is the wave, the level difference is talking about the tide, okay? So these are tidal waves giving us energy. So the wind is also there. The wind can be coming as a column. Coming as a column, okay? To turn what? Turbines, okay?